Now let us understand what is speed. Speed is how fast an object is moving. Okay, so that is speed. So we have to determine how fast an object is moving, and it is found using this formula. S for the speed, that is equivalent to the total distance divided by the total time, and this is what we call the average speed. So let me do it again. The average speed is equivalent to the change in distance divided by the change in time. So this will be our equation in solving for average speed. So average speed can be found by simply determining the change in the position of the object over the change in time. So this is change in position over the change in time, and that should be our average speed. So this will be our x here will be our time in seconds, and our y-axis here will be the position, or d, in meters. So at time 0, the object is located at 2 meters. Now at time 3, let us assume that the object now is located at this position, at that is 1, 2, 3, 4, 5 meters. Okay, that's 4. At time 3, the object now is located at this at time 6, 3, 4, 5, 6. At time 6, let's say the object now is located at this position. So that is 1, 2, 3, 4, 5, 6, 7, 8. So let me just put some labels here. So this is time 2 meters. This is 5 meters, and this will be 8. So that's 0. That's 1, 2, 3 seconds. This is 6. Now, what if we want to know the average speed of the object from 3 seconds to 6 seconds? So our task here is to simply find so find the average speed of the object from 3 seconds to 6 seconds. Let us now determine all the necessary data. So again, we have to look for the speed. We know that the initial time, let's say this is TO, is 3 seconds. Our final time is 6 seconds. Now we know that the distance or the position of the object initially at t equals 3 seconds, so at time 3, the position is 5. So this must be 5 meters. Now the position of the object at 6 seconds, so we have this 6 seconds, we have this 8, so this is 8 meters. Therefore, the average speed must be distance final or position final minus position initial, and for the denominator it's the time final minus time initial. And let us all substitute the given data. So for df, that's 8 meters, for do, that's 5 meters, and for tf, that's 6 seconds, and for to, that's 3 seconds. So we get 3 on top and also 3 at the bottom. So we divide and we get a value of 1 meter per second. So this means that the speed of the object is 1 meters per second, meaning that the object travels 1 meter in every in in every 1 second. Okay, so this is how we solve for the speed or the average speed of the object. If we graphically analyze this value, this 1 meter per second, if we look back earlier, this is 3 meters, this is also 3 seconds. We get this one by this. Okay, so this one has a length of 3 meters, and this one is also 3 seconds. And if we draw a straight line that connects this one, this hypotenuse, this red line is the slope, which is equivalent to the average speed. So in the sense, we could think of average speed as the slope of the line, this red line. Okay, so that is average speed. It's nothing but the slope of the line, this one. If you could still remember, the m equals to rise over run. So the rise here is the change in y, while the run here is the change in x. Okay, so we have here y minus yi and then x minus xi, so this could be ff, and notice that this m here, yf minus yi over xf minus xi, is actually identical to the equation we have in this one. So this clearly means that the speed is nothing but the slope. Now, we have also the term instantaneous speed. What is this instantaneous speed? From the word instant, instant, meaning the speed of the object at a given time. Let's say I want to know what is speed, the speed of the object at exactly, let's say, 5 seconds during its uh, motion. So if you want to know the exact speed of the object at the exact time, then you are actually looking for the instantaneous speed. Um, this is actually common to us because the speedometer gives gives us the exact instantaneous speed. So when you're riding your motorcycle and you look at the speedometer, okay, you look at the speedometer, then this actually gives us the instantaneous speed of the object at a given time. So I will not go into the mathematics of this concept, and I have a separate video that would detail all the mathematics involved with this topic. But for now, that is instantaneous speed, the speed of the object at a given time.